Alright, so here's your you try problem, example 3. If you got the answer right, just fast forward the video until you start to see the next problem. But I just want to give a brief explanation. 315 degrees would get you into the fourth quadrant, and then you have 45 degrees left between the vector and the x-axis on the other side. So 360 minus 315 is 45. So that's a 45, 45, 90 right triangle. And so we know the length of the hypotenuse is 15. To get from the hypotenuse to the leg, we divide by radical 2, just like we did in example 1. And so I didn't bother rationalizing our denominators, so you could do that if you want. If you did, great. If you didn't, then you got the same answer I got. But if you did rationalize, then you got the answer in the back of the book. So good job. I just get lazy with that. I don't think we need to talk about that. Waste time doing videos. But anyway, we'll do some practice problems in class. Hopefully you got example 3 right. And we're ready to move on to the best problems in the entire unit for vectors. These are the most fun. Definitely fun problems because it helps if you're really, really accurate with your drawing. So if you have a compass, or sorry, a protractor, I always get those words confused, but I know what they are. If you have a protractor that you can measure angles really, really well, then that's super, super helpful. And that's what I did here while I had the video paused. This guy right here is a 45-degree angle. So I just want to make sure we're understanding what's going on. Two forces are being applied to the same object. And one force is a force of 30 newtons. And that acts at a 45-degree angle. It's kind of like two people pulling a rope, and somebody right here at the origin is holding it, or two people are moving a box, or whatever, or pushing, or whatever. Okay, so a 45-degree angle is this first force, and then the other force is a 120-degree angle, and so we can think about that as 120 plus 60, so we're just going to tack it on to the other end here. So 120 from the horizontal to that other vector, and that's a 70 Newton vector. And so what I did was I used 5 millimeters per 10 newtons. So this guy right here is 15 millimeters long, and then I made this guy here 35 millimeters, or 3.5 centimeters long for this guy. Okay, so 15 millimeters here, 35 millimeters here. And so you can see the relative lengths of the vectors. And these kinds of problems are super important to draw them accurately, because then you can see, kind of get an idea or a feel for how long the resultant vector would be when you add the two vectors together, and then also the angle that that vector makes with the horizontal. So my drawing is pretty accurate. So the angle that the resultant vector makes with the horizontal is going to be a little over 90, and so forth. So let's think back to some geometry here. If that's 45-degree angles there, then what did I say right there? I don't know what the heck I just said. If that's 45 degrees, I'll have to replay that because I think I said something totally stupid. But it's 11 o'clock at night, and that's my excuse. So that's 45 degrees, and the angle in between these vectors, if that's 120, okay, so let's think about this. 120 minus 45 is 75 degrees. So let's write that in there. So it gets a little bit touchy here. It gets a little bit tricky to get all this stuff in here. So that's a 75-degree angle, and we need that because since we moved the tail to tip, and so I don't know if I talked about that yet. We haven't really needed to talk about that yet. So in order to add these vectors together and to get the resultant vector, the resultant force of these two forces acting on the object, then we have to move tail to tip. Remember when we added two vectors together the other day? We had to do that, so we have to do that here. And so if we extend this, and let's see, where's my ruler here? If we extend this guy here, then we can see, we can get a better understanding of what is going on. 75 degrees is the angle in between the two, so this has to be also a 75-degree angle right there. And that makes this a 105-degree angle. So all that being done, this is really the angle we need here, the angle in between the two vectors. Okay, And so that being a 105-degree angle, we want to find the length of the vector. Okay, and the length of the vector x, let's do that right up here. We know that we can just use, this is a triangle, it's not a right triangle, but you learn the law of cosines. When you have side, angle, side, you use the law of cosine. So x squared equals 30 squared plus 70 squared minus 2 times 30 times 70 times the cosine of 105 degrees. Okay, and so in your calculator you're going to just take the square root of all that stuff. Okay, and so I'll write it again. Should have done that. But anyway, the square root of all this stuff in here, and I didn't do this already, so I'm going to have to do it again, or do it for the first time, I guess I should say. 30 squared plus 70 squared minus 2 times 30 times 70 times the cosine of 105. And just give yourself a quick double check that you're in degree mode. And I am doing that same thing here. So yes, I am in degree mode. And we got 82.988. And be careful when you label these. It's not degrees, it's newtons. That's the length of that vector. So that's newtons. And so we're going to just put a box around that and feel good about ourselves that we got the length of the vector. So we got half of the problem right. Find the direction and magnitude. That's the magnitude of the vector. Okay, you don't have to write magnitude. I already know. If you write n, that's magnitude. Direction is going to be degrees. And so we need to find the degrees. By the way, you're going to store that value. That's really important. Store that, and I always store it in A, and so I'm going to just use A to represent that value. So STO is the button right above the on button, alpha A, enter, and that gives us that value right there. So I'm taking the answer, storing it in alpha A, because I don't want to use an approximation in a future gosh, it's late, calculation. So yeah, I want to store that value so we get the most accurate answer. Okay, so now we need to figure out what direction this guy is going in. Okay, well, think about it. We already know that this is 90 degrees, and we know that's 60 degrees. If we can figure out this angle right here, we need to figure out an angle inside this triangle here, so we can figure out what the direction is. And so, if we figure out that angle there, we can figure out the direction. So, let's do that. But let's not use the law of cosines. Let's use the law of sines. The sine of the angle theta divided by the opposite side, length of the opposite side, 30. Is equal to, sorry, I was a little crooked there, I looked up at my screen, is equal to the sine of the 105 degrees divided by, I'm just going to write A, because I already defined that A was my length of the vector. And then let's write this, the sine of theta is equal to 30 times the sine of 105 divided by the A. And let's just make a quick calculation here. Okay, so it didn't get too busy. So we have 30 times the sine of 105. And you can't even see that. I'm just going to do it off to the side. Sine of 105, and you should be doing this on your own as well. Divide by alpha A, and I got something 0.349, 0.3. I'm just going to write 0.35. And but I'm going to store that also in alpha B, because or I don't really need to store it because I'm going to use it. But I'll store it anyway because I said I would. But the theta then is equal to the inverse sine of, that's good that I stored it because then I put B right there. Okay, so the inverse sine of B. So we type in inverse sine, and if you still have it on your screen, just type in second answer, and it looks like that. Okay, and enter. So theta then is 20.437 degrees. I'm going to store that in alpha C in case I need to use that again. Okay, so 20.437. So we have theta then is approximately equal to 20.437 degrees. Okay, we still don't have the direction, because the direction that these two vectors were given initially were with respect to the positive x-axis. So we'll stay consistent with that. And so we would say the direction then, to find the direction. Let's figure out how we're going to do this. Okay, so adjusting things a little bit. Notice that if we take 60 and add it to that theta, we're going to get the end of we're going to get the angle on the other side. Okay, and maybe this isn't the best way, but it is one way, and you can, just as long as you're keeping your numbers organized, you're fine. So if we take 60 and we add it to 60 and we add it to the B, okay, then we're going to get 80.437 degrees. Okay, so let's think about this. 80.437 is the angle that purple vector, that our resultant vector, makes with this side here on the other side. So that's the 80.437, okay, degrees. Well, if we take that and subtract it from 180, then we're going to get the angle we need. We're going to get this angle right here. So it's let me think of a good color to use here. Let's use purple, since that's our so this angle right here is going to be 180 minus the 80.437 degrees. And that's going to be the angle at which our resultant vector makes with the horizontal. So we have 180 minus 80.437, and we get 99.563 degrees, and that's our answer. That's our angle that our resultant vector makes with the horizontal. That's kind of a cool problem. I hope you like that. Well, that took a long time to explain it, so hopefully you hung in there, and you're not staying up till almost midnight like I am. And the next video should be the last one, and it will cover the last page.